So let's do another example on this worksheet here. A rectangular page is to contain 30 square inches of print. The margins on each side are 1 inch. Find the dimensions of the page such that the least amount of paper is used. Okay, so I want to find the dimensions such that the least amount of paper is used. So I'm going to say that really means to minimize. So if we neglect, the width of the paper, we can think of the amount of paper as the area of the paper. The area of the paper, I'll call that A. Okay, so let's get an idea of what we're looking at. Here's our paper page, and it's rectangular, and then there's going to be 1 inch margins, so we actually have page in here where each one of these margins is 1 inch wide. Okay, so we have some choices. We could, since we're looking at the whole page that we're trying to minimize the area of, we could do that this is X and this is Y. Now, as it turns out, just from the way the mathematics is going to work out, and you wouldn't know this ahead of time, it's going to be a little messier that way. So what I'm actually going to do is let X and Y be the inside, the printed page, which would then make this X plus 2, because I have a 1 inch margin on each side, and that would make this width Y plus 2 for the same reason. Okay, so the area of the whole page is then X plus 2 times Y plus 2. Okay, that's my objective function. Now what about some constraint? Well, it has to contain 30 square inches of print, meaning this in here is supposed to be the print, and that's of area XY, and that has to be 30. Or in other words, Y is 30 over X. Okay, so that is going to allow me to go in there and get A, the area, as X plus 2 times 30 over X plus 2. If I multiply that out, and again now it's only going to be an X, that's going to give me 30 plus 2X plus 60 over X plus 4. Or in other words, 34 plus 2x plus 60 over x. And there is my area function. Oh, now again, we must have some restriction on x. Well, let me see. X, since the only thing that's restricted here is really x times y has to be 30. So x would have to be bigger than 0. Now technically x could go to infinity because we could have a really wide page that's very short. It's unlikely. So really x is just going to be greater than 0. So our whole problem here now is to, what do we say we're doing? Minimize A of x equals 34 plus 2x plus 60 over x on 0 infinity. Okay. A prime is then 2 minus 60 over x squared, if I take the derivative of a. When is a prime 0? When is a prime undefined? Well, a prime is undefined at 0, but A wasn't even defined there, so none for that. For here, if we work out 2 minus 60 over x squared is 0, we'll get x squared is 30. So x is plus or minus the square root of 30, but again, we're going to go to just positive lengths here. X is the square root of 30. All right, so we need to look at that. So 0 off to infinity. We'll just put the square root of 30 in there. Here's a prime. If I put, say, a small number 1 in there, I'll definitely get negative. If I put some really big number in the denominator there, that's going to make 60 over x squared really small. So I'm going to get a positive from 2 minus that. And as we were expecting, we have, oh sorry, this was a prime. So here a is decreasing, here a is increasing. And that would tell us that here is the relative min, but it also has to be the absolute min. So that tells us we should let x be the square root of 30. Realize a y was 30 over that. So y is also the square root of 30. And that's not the dimensions of our page. Our page is actually x plus 2 by y by 2. So x plus 2 is 2 plus the square root of 30. Y plus 2 is 2 plus the square root of 30. So the page should be 2 plus the square root of 30 by 2 plus the square root of 30. That's not surprising that if we're going to maximize our use of the paper, we should make it square. Now that's interesting because they're saying that basically if you want this printed item, this page, to maximize the space used or minimize the amount of paper used, that you should make it square. Now most of our books are not square because there's a lot of other things that go into the reality of this. In other words, the margins may not be the same 1 by 1 on every side. Also, people may not like a square book as much as a rectangular book. So when this is used in true applications, there's a lot more than just the maximizing and minimizing of certain quantities that goes into play. But this gives us a good analysis of what we should be looking at. And that is the idea of optimization.